what does it mean to solve functions? If you had 2x equals 8, what would you do to both sides? You don't have to write this part down. What would you do to both sides to solve for x? Right, divide by 2, so x would equal 4. So that is a linear function that we just solved. What if I said, huh? No, we're going to do 154. I'm just giving you a little precursor FYI. What if I said x squared is 25? What would you do to both sides to solve that equation? Square root both sides, right? So x would be either positive or -5 because we learned there's two solutions to quadratics. So we're taking the inverse operation. So if I ask you 2 to what power is 32, what operation can I do to both sides? I can't divide by 2 to get the answer. I can't multiply by 32 or subtract. I can't do an operation right now. I don't know the inverse to exponential functions. This you could solve in your head using mental math because it's in the table of powers. So if you look for 32 in the table of powers, it's 2 to the 5th power is 32. So x would have to be 5. So today we're only solving exponential functions that we could either do in our head or use something called the one-to-one property, which I'm going to show you. Next week, our goal is to be solving equations using logs. So a log is the inverse function to exponential functions. We don't know how to do logs yet, so we can't get any further unless we could just use mental math. So if I asked you 2 to what power is 17, I don't know the answer to that. I know that 2 to the 4th is 16, so the answer is probably 4 point something, but I don't have a mathematical operation yet to solve this. So we're working towards solving this type of problem. But today we're going to look at solving exponential equations with the one-to-one property. So it's another strategy before learning logs. So it says one of the ways to solve exponential equations is to get the same base on both sides of the equations. Once we do that, we can ignore the bases and just find the x value that makes the exponents equal. So for example, in example 1, the bases are already equal. 5 equals 5. So if the bases are already equal, what does x have to be? I already know that x has to be 7 to make this equation true. In example 2, the bases are already 3. So I can focus in the exponent. I know that x plus 1 has to be equal to 2x minus 1. So I can set the exponents equal to each other and then use my just regular old solving strategies to solve for x. So I would subtract x from both sides. So I would get 1 equals x minus 1, right? I subtracted x from both sides. And then I would just add 1 to the other side to finish. So x would have to equal 2 in example 2. So if the bases are already the same, then you're good. You could just set them equal and solve for x. And then it says if the bases are not equal, we should look to see if the bases are powers of the same number. So for example, that's this power family, right? Are 25 and 5 members of the same power? It says yes, they're both powers of 5. So they've already done the work for you in this example. They took 25 and they transformed that into 5 squared. So 25 is equivalent to 5 squared, and they left the x out there because that's 25 to the x. So now I've got 5 to the 2x equals 5 to the 4th. So down here they said since the bases are the same, we can just set 2x equal to 4. So x would have to be 2, right? If 2x equals 4, then x equals 2. So this was really meant for like virtual, if you see this during a video. But so this is kind of just explaining it to you. It says, remember, we can check our solution by plugging in the values of x into the equation. So if you plug 25 squared in and 5 to the 4th in, they come out to the same number. Yes, they do. We'll save time to do that. All right, so take a look at that table of powers, or I mean, I can project it too, but you should have it. It's right behind your agenda for this part of the unit. So we're looking together. I don't want to take too much time on this, but what family do each of the numbers belong to? So I see 81 in two different power families. The power family is the bold number. So the 2 family, or the 3, 4, 5, 6, 7, 8, 9, 10, those are the bases that we're looking at. So see how 81 is in the 3 family and it's also in the 9 family. So 81 falls under 3 and 9. So on my little note sheet, I'm just indicating what 2 families it belongs to. So could you try that for the other like 4 numbers? Find what power families using that table of powers. If you can't find it, I'll just project mine. Some of them might only belong to one of the families, so that's okay. I just found out that there's a typo on this key, because if you look under x to the 8th, what's 128 times 2? This should be 256 right there. Sorry about that. Hopefully there's not other typos on the key, but typing all these numbers in took a while. So actually 256 should belong to 2 different families, but you might have missed that because there's a typo on that table of powers. If you see another typo, please let me know. But see how there's a x to the 8th? 128 times 2 is 256. And then 256 times 2 is 512. So I know 512 is right, but that top row, there should be a 256 where I just circled. So 256 belongs to 2 different power families. So I'm going to show you why this is important. But did you kind of get this? So we got 125, I think, only belongs to 5, right? 1/7 only belongs to 7. 216, I think, does it only belong to 6? That's the only one I saw. Did you see another one? And then 256 belongs to both the 2 and the 4 power family. All right, so why do I need to know that? So we're going to use our power families now on this page. So here are the kind of, 7 levels of solving for x. And then next time we'll be able to start with kind of a guided practice and see if you got it. So after the quiz, this won't be on the quiz tomorrow. So the quiz will just be through fractional exponents. The quiz won't include solving exponential functions. So level 1 we already talked about. You can just set the exponents equal to each other. So I can see that in number 1, x has to be 3. And in number 2, x has to be -2, right? Because I have to set the exponents equal to each other. Level 2, all of these is kind of mental math. 2 to what power will give me 8? So what would you say? X has to be 3, right? Because 2 cubed is 8. All right, what about this one? What power do I have to raise the power of 3 to get to 1/9? If you look over in your chart, here's 3, here's 1/9. It's the -2nd power because you're squaring it and you're flipping it upside down, reciprocal. All right, so level 3 is basically the same as level 1. There's already a common base, but now you have to solve the linear equation yourself. So in example 5, you're solving that 2x plus 1 has to equal 7. So you're just focusing on the exponent this time. So to solve that, you're using linear algebra here. Subtract 1 from both sides. That would give me that 2x equals 6. Divide by 2, and x would have to be 3. Number 6, you can probably figure out mental math. What would x have to be in number 6? Right, so when you divide by 2, x would have to be -3 to solve that equation. All right, so that's the one-to-one property. gets a little bit more challenging. So find a common base this time. So I've got 2 to the 4th on this side, and I've got 4 to the x on this side. You might be able to do these in your head. I'm just showing you what the common base would be. So I can bring 4 down to the 2 family. So I'm going to leave 2 to the 4th on this side, and I'm just going to rewrite 4 as 2 squared, right? Because 2 squared is 4. So, and then I'm just going to put the x on the x outside of that parenthesis. So really 4 has to equal 2x if I set those exponents equal to each other. So if 4 is equal to 2 times x, x has to be 2. And that should make sense because 2 to the 4th is 16 and 4 squared is 16. So when I plug it in, it works. 8, you might not be able to do 8 in your head like you could probably do 7 in your head. So we want to make 27 go down to a power of 3. So 27 is 3 cubed. So see why you need to know kind of the powers of the different numbers? 3 cubed is 27. So I've got the x on the outside of the parenthesis. So I multiply. So 3x has to equal 6. So what would x have to be? Divide by 3 on both sides. So x is 2. So you don't need a calculator to do this type of problem. I'm not telling you to do 3 to the 6th power in your head. You actually are just solving a linear equation using the exponents. And then the next level down, it says it's like level 4, but sometimes you get a fraction or a negative exponent as your answer. So that's not that big of a deal. 9 and 27. So they come from what power family? 3. So you're going to rewrite them both as a power of 3. So 9 is 3 squared, and 27 is 3 cubed. So I've got 3 squared to the x, and I've got 3 cubed on the other side. So I really am setting 2x equal to 3 and solving for x. See how you get a fraction as your answer? X has to be 3 halves. So it's not, to me, it's not any more challenging. It's just a little bit different because you get a fraction as your answer. Number 10, what power family should I use for 4 and 8? So if you go back, they only are both in the 2 line. There's 4, there's 8. If you tried to use 4, 8 is not in the 4 family because 4 squared is not 8. So I'm going to change them both to the 2 family. This is 2 squared to the x. And how would I write 1/8 as a power of 2? So if you forget, go back in your table of powers. Here's 2. Here's 1/8. So it's the negative 3rd power to get 1/8. So I'd have 2 to the x, so 2x equals negative 3 this time. So x would have to equal negative 3 halves when I solve for x. So it came out just, it's just a linear equation that you're solving at the end. All right, number 11 and 12, we learned how to do today. So these are all square roots. So the square root of 16 is 4. So what would x have to be? What type of fractional exponent is x? 16 to what power gives me 4? They're square roots. Do you not know? 1/2. Thank you so much. Oh, at least someone's thinking it. So 16 to the 1/2 power, that's the square root of 16, right? Same thing with number 12. 100 to the 1/2 power is the square root of 100. See how your brain should start to be thinking about the relationship between the powers of the numbers. And the last one is just said, did you call me a 0, right? Anything to the 0 power is 1. So in 13, the answer would have to be 0. What would the answer have to be in 14? If this is 9 to the 0 power, what does x have to be? Negative 3. So that's where we're stopping for